to our data collection sort of branch of our plan for today. It's really my pleasure to introduce Ashton Verdery. Ashton is a PhD from UNC, so it's back home in our part of the world. And he's now at Penn State. Who, can I tell people?
Yeah.
He was just promoted to full professor.
Oh.
Just got congratulations to Ashton. He's been one of the leading sort of voices in respondent driven sampling. This is a way of collecting network data by letting your respondents sort of work through your population, and it's a really powerful way to collect data that's otherwise almost impossible to get. Like all good things, nothing is free, and so there's constraints and problems with it, and Ashton has become one of the world's leading experts in how to actually figure out and get good estimates from these kinds of data. So it's a real treat to have him here today, so thank you, Ashton.
Thank you. Thank you for the introduction. It's always a great pleasure to be back here. I want to emphasize, although I did my PhD at UNC, I spent equal amount of time over here hanging out with Duke, so I learned quite a bit from the Duke Network Analysis Center. Today I wanted to talk about network sampling, give a kind of basic overview for why you would want to do it, and kind of contextualize this problem of there are lots of populations that we're interested in that we think have social networks, and we can use the network to learn something about them. This, I think, will lead into kind of a subsequent consideration of what if we also want to learn about the network. And I want to emphasize respondent-driven sampling is typically not very good at learning about the network. It's good using the network, but it kind of obscures what the network actually looks like. So I'll talk through the kind of concepts of RDS and some of the big challenges that it still has and some of the kind of opportunities that it has. And then I'll try and conclude, if I have enough time, with some alternative approaches that emphasize rethinking how we're collecting the data and some of the opportunities that are available for that in certain circumstances. The basic idea is that you're looking at a population. We know many populations are connected to one another, so imagine there's some underlying network here, and we want to sample it, but we can't go out and sample individuals because we don't have a clear measure of it. But we can start with one person in the network and say, refer us to a friend of yours, and they refer us to a friend of theirs, and we can go through the network through this kind of referral-based sampling procedure that's familiar with snowball samples and other things like that. These ideas have been around for decades, but what's exciting about respondent-driven sampling is starting in the late 1990s and taking off in the 2000s was the realization that we could leverage this process that social scientists have used for a long time to collect data to collect data that you can then generalize to the network itself. So you can learn things about the whole network from the sample of people you collect through this referral-based process. So why would anybody want to do this? I actually feel like kind of always between a rock and a hard place on this because I see a lot of problems with RDS, but I also recognize that I think that these kind of approaches of novel data collection formats, approaches that don't rely on standard randomized data collection are really the way forward for social science. There are lots of populations that are of interest to researchers that are difficult to study with the traditional format. I think the idea that you could knock on undocumented immigrants' doors as a researcher with little connection to the community and expect to be able to have them respond to your survey is very unlikely. So there's lots of populations we want to know about that we can't collect data without some sort of community access to them. Also, as we're learning about here, there's all sorts of new tools that we can apply to kind of network data to learn new things, test key theories about relationships, structure of society, and things like that. And then I think the big one that I often emphasize is contemporary surveys are in an existential crisis, which means the entirety of the social science enterprise, or at least a very large portion of it, is in existential crisis owing to response rate declines. To kind of emphasize that, here's a graph of response rates for dozens of about 8 big surveys that have been repeated over time: General Social Survey, National Election Survey, Panel Study of Income Dynamics, and things like that. And survey rates, you can see, have fallen off a cliff since the 1990s, and they're continuing down quite a bit. On the other graph, this is one that I found from the Panel Study of Income Dynamics, which has done a good job of maintaining higher response rates. It's one of the ones that's closer to up here. But they've done that in the face of escalating costs per recruitment, which means that all the money that's available for social science research is increasingly going to collecting these data and kind of crowding out other kind of social science endeavors. I'll take questions at the end, if that's all right. So I think there's good news in some ways that There's some people arguing that survey response rates are bottoming out, but they're bottoming out at extraordinarily low levels. This is from Pew, and I kind of always harp on this graph because they tweeted, look, this is great. Survey response rates have bottomed out at less than 10%. And if less than 10% of the people that you're collecting data from or attempting to collect data from are responding to your survey, there's great potential for kind of survey response biases to come into the process. Respondent-driven sampling and many sampling methods are motivated around this idea of trying to collect data on hidden populations. Hidden populations are defined as those that lack a sampling frame. That could be because people don't want to be found. They're just kind of unregistered in kind of the basics statistical systems that we have. They might not respond in general if people come up to them. And they might be an extraordinarily rare population. So there's a lot of techniques around the kind of different scientific fields for collecting hidden population data. There are techniques from ecology, for instance, to collect data on kind of rare animals that could be applied. But it's a bit of a challenge because unlike with animals in kind of a forest, you can't just grid up the space and then randomly sample. You have to have quite a bit of community information to be able to collect that data. So the traditional way this is kind of taken on in the social and medical sciences has been what I would just call a set of convenience samples. You collect the data that you can collect. Who's in your clinic, the people that you can find on street corners if you're interested in surveying populations of people who are unhoused, or other kind of activities that are similar to this. The challenge with all of them is that it's very difficult to make a strong argument that you're learning about more than the individuals that are in your sample. And that's often what we want to do. So we want to make an inference to some larger population, not just the 200 people we talked to, but the 2,000 people that we think they're representative of. So there's very limited ability to kind of infer representation. We don't know how well we might have covered the sample frame. There's often with convenience samples, it's very difficult to count a response rate, for instance, because we don't have a sampling frame. And other kind of challenges are that it's time intensive, costly, and sometimes dangerous to survey in these conditions. If you're sending people into kind of homeless encampments, there's all sorts of researcher risks that you also need to consider in addition to kind of dangers for the population themselves. So to kind of attempt to address those issues, in the late 1990s, Doug Heckathorn, a sociologist, proposed this procedure called respondent driven sampling, building on classic ideas of snowball or referral-based sampling in qualitative and other research areas. He argued that if we make some modifications to the data collection procedures in snowball sampling, we can come up with a method that allows us to make generalization to a population. So the key innovations that he proposed were limiting the number of recruits that each person could bring into the survey. So rather than one person, say, bringing in 5, you try and have one person only bring in 2 to kind of extend the chain further in the network. And second, using a series of statistical estimators to make adjustments to the resulting data to allow us to make generalization to the population. And I'll go over those in a bit. RDS has become hugely popular. It's a huge kind of endeavor. There's over 1,700 publications as of last year on respondent-driven sampling. NIH has funded over 120 studies with $59 million worth of kind of funding of collecting RDS-related data. And if we compare it to other network methods, it is like the big gorilla in the room in terms of kind of federal funding and amount of studies that are collected with it. If you compare it, for instance, to egocentric data collection methods funded by NIH or NSF, you see just an order of magnitude different levels of funding. This approach for respondent-driven sampling, I want to emphasize, it's most often used for kind of health-related research, but it is actually widely used for other social activities as well. So probably the biggest population that is surveyed with RDS are people who inject drugs. Second to that population are other groups thought to be at key risk of HIV, including commercial sex workers, high-risk heterosexuals, other people who use drugs. It's also been used to study other kind of difficult to survey populations, including survivors of wartime rape or vegetarians and vegans for a less kind of depressing topic. It's also used frequently to study things like social kind of groups that we think might know each other but aren't studied typically in the social sciences, like jazz musicians working in New York or things like that. The most common questions that RDS are asking in its kind of application are, what can we learn about the population overall? And typically the big quantity of interest is trying to estimate some prevalence statistic. For many of the HIV-related applications, that prevalence statistic is what proportion of people have HIV or are engaged in key health risk behaviors, including like sharing needles or sex without condoms, to better understand, is this a population that needs kind of further intervention or surveillance? There's also a subset of questions trying to seek out what size the population is. As I mentioned, RDS is mostly used in the health fields, so public health, infectious disease, substance use, that's the bulk of it. But there is some work done in other kind of areas, including sociology, psychology, and things like that. So I said Doug Heckathorn came up with an approach to make snowball sampling kind of palatable to be able to create this generalizability to the kind of overall network. The key insight that he had is this twofold procedure. The first one is to change the way that people are referring to one another by limiting the number of limiting the number of coupons that individuals can give out to others to kind of make the chain go broad in the network. So you typically have this chain referral, peer recruitment kind of endeavor, starting with a set of seed participants, your initial sample people that are selected by convenience. Those people are each given 2 coupons. Then they're asked to give 2 coupons to, or give 1 coupon to someone else. When that person participates in the study, they get 2 coupons and are asked to then continue that process. So by limiting the number of coupons, the thought is that the sample will go further into the network. So that's this procedure here. It typically creates structure so that nobody participates more than once. The researcher lacks control of the sampling process, and often people are incentivized to recruit others into the sample by creating sample incentives that say, give you $10 if you participate and $5 for each person who redeems a coupon that was initially given to you. So that gives this kind of dual incentive to participate. The second innovation that Heckathorn had was to weight cases after the recruitment procedure occurred. And it kind of connects weights to the theoretical sampling procedures that networks like this, or that a diffusion process like this would take in a network, and gives higher weights to people that are more popular. So if you are kind of randomly passing around coupons in a network, the people who are more popular are more likely to receive those coupons. So they get weighted down, and the less popular people get weighted up. I did say that backwards, but initially, sorry. And from that, you make population inferences to try and understand what the statistic of interest in the population is, as well as quantify uncertainty. So as I mentioned, typically RDS, you give out coupons. The practicality of this is you usually start with 7 or 10 kind of individuals in the initial wave. You give them 2 or 3 coupons each, and you typically ask those individuals to hand out coupons to people that they know who don't know each other, or at random amongst the people they know. Coupons typically are used to track these chains of recruitment, so I can tell that I gave you a coupon, and then the coupon that you gave to, say, Jimmy Adams in the back, that I could tell that you were the person who had it, although nobody else can because it's anonymized through kind of basic coupon numbers. There are other features of the coupons that typically you want to put a valid date so that they're not sitting out there forever, and kind of describe where the survey site is and the details of the study. And the resulting data that is typically derived from respondent-driven sampling looks something like this. This is from a data set that Giovanna Merli collected, I think with Jim, in Luzhou, China, where they sampled female sex workers. So they started with 7 kind of initial individuals that they recruited through kind of a convenience-based approach. They gave them each a few coupons. Those people are listed at the top. And you can see one of them recruited nobody. But the first one, this big chain over here, that person recruited 2 individuals who then, each of them recruited subsequent individuals. And this is how the data kind of typically comes in. And what you see is that the pink nodes, which are kind of people working in one tier of sex work, tend to recruit people in the pink nodes. The blue nodes tend to recruit people in the pink nodes. It does kind of reflect the underlying network structure, but it does generate this kind of network process that samples pretty deep into the network. So this one seems to have gotten into some of the blue nodes, for instance. You take those chains, you kind of aggregate them together, and based on respondent degrees, you weight the data to come up with an estimate of the population prevalence. There are a lot of resources for RDS. I don't want to go through all of these, but I do want to point you to some really good kind of websites for RDS implementation and key manuals from the CDC and the World Health Organization and others. There's also great R packages for RDS kind of data analysis, as well as some Stata packages for those who are interested. So you might ask yourself, how would this work? Why would it work? Like, what should I do to make it work? And just like any sampling method, it relies on assumptions to make it work. And to the extent that these assumptions are plausible about your network, there's a good reason to suspect RDS might be able to generate an unbiased estimate of the prevalence. So the basic assumption is that there is a network connecting the people. I think this is often overlooked, and I sometimes hear people suggest, oh, I want to do an RDS on people who don't know anybody else, and that sort of thing. And that's obviously not going to work. So you have to keep in mind that the people who don't ever leave their house and don't know anybody else wouldn't be a good population for RDS. There are other populations that might not be good as well. For instance, I've been asked to help someone come up with an RDS for people who visit commercial sex workers. And one challenge with that is, I think in that population, through formative research, we found that not a large percentage of them actually knew others who visited commercial sex workers. They knew commercial sex workers, but they didn't know other clientele of the commercial sex workers. So there are situations that you need to be careful to think about that. Another assumption is that the population size is substantially larger than your planned sample size. RDS tends to perform poorly when, say, you sample 90 of the 120 members of the population, because some of the estimators rely on this without replacement kind of sampling design, which necessitates a kind of population size being much larger than the sample size. Other big assumptions are that homophily in the network is relatively weak. The network's community structure is relatively weak, so it's not highly clustered. That the graph is connected with one giant component. That's a more stringent assumption than there is a social network, but technically all the estimators make that assumption. It also typically assumes that all ties are reciprocated. Some of the population estimators make assumptions that you know the population size, but that's not true for all of them. So these are assumptions about the network structure. There are also assumptions about how the sampling proceeds. In general, the most important one is that individuals are recruiting without preference among their kind of contacts that they have. So they don't, and I'll reveal that or I'll discuss that in greater detail in a minute. There's also assumptions about sampling with replacement. Traditional RDS kind of estimators made that assumption and made an assumption that there was a single non-branching chain with only one coupon per person, which is kind of prima facie invalidated. But later kind of methods relax those assumptions. I'll talk through some of the key concepts and kind of highlight why some of these assumptions are issues. So RDS, I mentioned, has this second component where you're weighting the data. The idea there is that you weight the data based on the likelihood that people would be sampled through that procedure if it were to be repeated an infinite number of times in the network. A simple way of approximating that is respondent in degree, or in an undirected network, respondent degree overall, right? More popular people are more likely to be sampled. Just thinking about how coupons are being passed and that sort of thing, you can imagine that if you have 10 ties coming into you, you might be 10 times more likely than someone who only has one tie coming into them to be sampled by coupons passing through that network. We have tested this, Jim, Giovanna, and I in different circumstances tested this, where we took kind of empirically observed social networks and we simulated millions of RDS samples through them, and we calculated how many times were individuals sampled in them and how well does that kind of degree-based estimate approximate that. And it does pretty well, but there are some circumstances that it doesn't always work perfectly. Typically, from an operational standpoint, we have to operationalize how we're measuring respondents' degree. So it's typically asked in this sort of undirected format, how many people do you know that you know them and they know you and they're in the population? to get a sense of like how likely it is that people would be sampled. The other part of RDS is the recruitment part. So there's the estimation part and the recruitment part. The recruitment instructions, I think, are sometimes overlooked, but the idea here is that you ask people to recruit their network members semi at random. The statistical theory is that they're recruiting randomly amongst people they know, and this is how that's operationalized and explained to respondents to get them to do that. But you'll notice here, it says things that are not exactly concordant with the statistical theory of conditional random recruitment. Here it says, give the coupons to different types of people you know, for instance, which is not exactly the same thing. I've mentioned a few times this idea that we're kind of conditionally recruiting at random. So this is what's assumed, that node A, who knows B, C, and D, who have different kind of attributes, either circles or squares, has equal likelihood of recruiting any of those people. What's important to recognize here is that A has a higher likelihood of recruiting a circle, 3 9s plus 3 9s, right? And so there is this kind of likelihood that you might end up, if thinking of the graph earlier, if you're a pink node, being more likely to recruit a pink node. But within the actual structure of the network that they have, that each tie has an equal probability of being sampled. The challenge, however, is that we often see this kind of preferential recruitment. It might be that people are more likely to recruit people who look like them or by other attributes. This could go in other ways as well. You could have the reverse situation where people might be more likely to recruit people who they think need to be in the survey to get an HIV test, for instance, which can lead to severe biases. So to kind of wrap up what I just said, it's not that people have differential levels of connection. That's not a problem for preferential recruitment. The real problem is that individuals might choose to recruit within their kind of set of connections preferentially based on some attribute that could bias the results. An under-theorized aspect of this is there are actually kind of multiple behaviors that go on in these recruitment processes. It's not just me going out and handing out a coupon to someone I know. There's also the process of that person saying, oh, sure, I'll take the coupon and be willing to participate in the survey. And then once they've taken the coupon, the next day showing up at the survey site and not forgetting the coupon or having it stolen or something like that. These 3 different procedures can really kind of create different levels of bias. I did test this over time. And found that the biggest danger is this reporting bias. If people throw out the coupons when they receive them, that can generate serious biases. Second is actually accepting bias, and then offering bias actually makes the least difference. But it's the one we talk about the most. So with RDS, we typically graph it like this on the bottom. You saw the graph I showed earlier of how the nodes kind of unfolded in what are called these waves. So you have a seed node, then a first wave, and then a second wave. We typically represent the data collection like that, but in practice, what actually happens in the field is that individuals are recruiting kind of over time, and there is kind of potential for someone who's in a wave to be recruited sooner than someone who's in a different wave, right? For instance, this person here is in wave 2, and then you have 2 people from wave, one person from wave 2 and 1 person from wave 1 recruited at time 4. So you can get some kind of reversals in time ordering that are worth paying attention to. In addition, typically RDS has got a primary and a secondary interview. So there are kind of opportunities based on the time that people show up to get their second incentive or their first interview to kind of learn more about how the network might be changing over time. This is greatly underutilized in my opinion. So I would recommend doing a better job of taking account of kind of questions about how many coupons did you try to hand out, not just how many coupons did you hand out. You can take advantage of that through that kind of timing of the data collection activity to get a sense of those potential biases. This is illustrating what I was trying to say earlier, but I'm just going to skip it. So if you were doing an RDS sample, I think it's helpful to know that structurally it is geared towards gravitating towards the center of the network. So this is the Project 90 Colorado Springs network that Jim put up earlier, and I did an RDS sample on this network starting from a node up here, which I happened to just pick at random. Starting from that node, each of the black nodes is one that gets sampled. And you can see just in this one sample, it tended to be that it ended up sampling the kind of center of the network, which is the basic principle of degree centrality and centrality. These things, something flowing through the network will end up kind of hitting the center of it more often. Another problem with RDS is this idea of bottlenecks. This is the case when networks have large kind of community clusters that have a lot of ties within them, but few ties between them. And this is a particular problem for RDS when that structure overlaps with some attribute of interest. So here's a case of an ad health network where I just took the races of individuals. And you can see this is a pretty segregated kind of school friendship network. If you did RDS sample on this, a lot of times, you end up with high variability in the estimates that you get from it, owing to that kind of bottleneck structure. The classic example was from a Salganic and Heckathorn paper early on, where they argued if you had a structure like this, the key thing would be to split the network and do two separate RDSs in that circumstance. However, that can be difficult to kind of know a priori if there is that structure in the network, in which case you could end up with severe biases in your estimates. Speaking of kind of biases, I wanted to review some basic concepts about how RDS performance might go. There are generally two prime considerations with RDS, which are not true with traditional random sampling. Traditional random sampling, we usually just care about how biased it is, and we don't care about the variability, because we know if we take more cases, variability will go down. That's not guaranteed in all RDS samples. So in RDS samples, you can have something that's biased, meaning it's far from, like, the average of the, if you repeated it 1 trillion times, the average of that distribution of mean estimates would be different from the population mean. But you can also have something that has high variability. So maybe it's unbiased, but each individual sample is kind of more likely to be far from the actual population parameter of interest. So one problem for RDS is the nature of this peer referral. Issues like the bottlenecks and that sort of thing create high sample-to-sample variance. So if I do one sample and I get a sample mean with HIV of, say, 40%, and I do another sample and I get a sample mean of HIV in the same population with 80%, and if I do that a lot of times and I end up concluding that in this network we have 95% of the samples would be between 10 and 90%, that's not a very useful kind of estimate of the HIV prevalence in that population. It's sort of saying, we have no idea what it is, right? And that's the challenge that RDS faces, that each individual sample is not necessarily going to be close to the population mean, although on average they tend to be unbiased. So in this circumstance, I took the Project 90 network and I repeated simple random sampling and RDS sampling to try and estimate how much more variable is RDS than simple random sampling. So both of them, it's the same network, so it's about a 75% kind of population prevalence of people being white in this population, which is the outcome that I was interested in. And I repeated samples, and I kind of graphed the mean of each of those samples. So I did 60, 70, et cetera samples with RDS, and simple random sampling, I believe, without replacement on this population. And you can see the distribution of the RDS samples. Each one I'm kind of stacking up one sample on this histogram, right? The distribution of the RDS samples is much, much larger than the distribution of the simple random samples. And if I were to increase the number of people sampled, the simple random sample distribution would get even closer around the mean. The RDS sample is not guaranteed to do that. And this illustrates that. If you increase the sample size in each case, you have the same problems. In general, RDS samples are known to have this kind of high sampling variance or variability in the estimated mean from sample to sample on repeated samples in the same population. However, this can only really be estimated either analytically or with kind of simulation methods like I just did. Empirical evidence on this, which tries to approximate it, suggests that it actually performs substantially better. So there are repeat RDS surveys that are conducted every year in the same population, say people who inject drugs in Seattle, and they're finding relative stability in those numbers that would not be expected from the kind of statistical results that are found. It's not it's not entirely clear why there's such stability. I think in some ways, the coupons end up being distributed more randomly than we think they are. So early RDS work really tried to focus on bias. Later RDS work recognized this huge amount of sample-to-sample variability, and subsequent work has tried to kind of quantify how uncertain the estimates are from any given sample that you take. The problem here is that the results typically suggest that we can't quantify that very well. The estimates of sampling variance don't tend to reflect the actual sampling variance that is seen in the population, which leads to a big problem for inferential statistics. Essentially, we're coming up with RDS confidence intervals that say HIV in this population is between 20 and 30%, but in reality, if we were to repeat the procedure on the same population, we should be saying that it's between 10 and 40%. So that lack of kind of coverage of the true confidence interval is a potential problem. I mentioned earlier there are a lot of estimators for RDS. At least 11 are in current use, and there are some newer ones kind of proposed as well. These estimators make different assumptions about the social network, different assumptions about the recruitment process and related activities, and they tend to perform better when those assumptions are violated or not violated. So there are ones that address this idea of sampling with replacement, and that does a great job of kind of correcting that bias. Very few of them there are very few estimators for kind of sampling variance, and in general they tend not to work as well as some of the core mean estimators, but some of the later ones like the tree bootstrap method tends to do a much better job. To illustrate this kind of bias in the sampling variability, I just took two networks that look kind of different, but have a lot of the same local level statistics. And what the problem for this kind of estimator is that running RDS samples on this and calculating the sampling variance that you would expect, you end up with the same estimates for the variance from these two, but actual different levels of variance. So it's kind of a fundamental demonstration that this is not working the way it's supposed to be working. An important part of RDS is trying to assess how violated the assumptions that you're making are. And so there are a number of diagnostic tools that have been proposed to kind of try and get at that. So there are questions about asking people who they recruited and why they did so. Questions about asking people, you said you knew X people, how many people do you think wouldn't say they know you? So you get like this sense of kind of reciprocity in the network, that kind of thing, to quantify those things. There are also efforts and diagnostic plots to quantify potential bottlenecks in the network. So for instance, this, if you were to stop the sample here, we would think this one's in a bottleneck. But as the chains evolve, maybe they're no longer in these bottlenecks of recruitment. An underappreciated issue that I've been working on lately that I kind of wanted to highlight because it's a graduate student in statistics that I've been advising, Alina Kuvakar, and she's doing a great job and about to finish and take a job at Pitt, is this idea that RDS unfolds in a kind of dynamic network, even though we always assume that the network is static. And so I mentioned here, this is how we graph it, but in reality, it's unfolding over time. And we looked at a few different RDS studies, just like, can we find any that were kind of egregiously long periods of time? And we found a few, and there are more, but that took, this one took 3 years to fulfill the kind of sample size of the network, in which case the network might have changed really dramatically over that period. And so we did a variety of tests using stochastic action-oriented models on an underlying network. As that network changes, how much does RDS kind of lead to biases from the population parameter? So in this case, this is the value at the initial time point, or the prevalence estimate at one time point. And if you run RDS kind of on the initial network, you end up with a good kind of measure of it. But as the RDS kind of unfolds, it gets further and further from the true population parameter if you run it on a kind of dynamic network, which suggests that this network dynamics could be a potential problem, and we should be paying attention to how long the survey is in the field, as well as coming up with new diagnostics to determine, is the network changing rapidly underneath while the sample is unfolding? One question that I got a bunch of times when I've presented this in the past is what about trying to run respondent-driven sampling on the web? This is sort of a key frontier area the classic RDS approach is you have a clinic downtown and people show up to the clinic and they participate. But it would be huge for the method if we could come up with ways to run this online where people don't have to show up to clinics, and you can, for staffing reasons, safety reasons, deductive disclosure, if someone sees them at the clinic reasons, there's all sorts of reasons that it would be preferable. In general, there hasn't been a ton of studies that have done what I would view as a great job of web-based RDS, although a few are kind of in review right now. I read one recently. Typically, you need a lot more seeds for dynamic RDS to work. Typically, you need strong verification systems to prevent people from cheating on the survey, like filling it out multiple times themselves, especially if you're using that dual incentive structure. Because like, if you say, I'll give you $5 for each person you recruit, and then I like fill in a few more extra surveys, I'm making more money. So it's kind of geared towards kind of introducing potential cheating on the sample in that circumstance. So IP address verification, et cetera. It's also difficult to verify the respondent is in the target population online. So if you are doing an RDS and you run into problems, the typical kind of recommendations are, well, get more seeds, just get new people into the survey. In addition, you might want to expand the number of allowable recruits. Often people start with 2 coupons given out to each person, but if we were to think about it, maybe sometimes it would be beneficial to give out 3 just to get more people into the survey. Typically, other ways to do it are raise incentives or reduce burdens to survey participation. And I think that even if all of those things fail, we can still learn a lot from an RDS sample. Just treat it like a convenience sample that's not that different than convenience samples on which people publish all the time. And we can learn about other features of the network, for instance, through qualitative interviews or kind of network enumeration or that sort of thing. So towards that last end, I recommend embedding additional data collection in RDS and examining questions more than just prevalence, trying to understand something about the network structure, for instance. RDS has a lot of potential. The weighting procedure does do a pretty good job of creating unbiased samples, but the big pitfall that it faces is this sampling variability, the ratio of the kind of variability of a set of repeated RDS samples in the same population to a set of simple random samples in the population is very high. And so you typically need a much larger sample size in an RDS study to achieve the same level of statistical precision that you would achieve with a simple random sample in that population. But it's a very fast and effective method typically, and it can be used to learn a lot about networks. If you are interested in alternative approaches, I'll give a plug for some work that Giovanna Merli and Jim and I kind of worked on at different points in time, suggesting that RDS's innovation came from changing the way we were doing recruitment and then changing estimation procedures. And I think that if we further think about changing the recruitment procedures, we could actually end up with even better kind of samples from that. There have been a lot of work trying to create new estimators for RDS, but much less work thinking about new ways of getting people to recruit people into the sample. One way that that can be changed is through this network sampling with memory approach that Giovanna Merli and Ted Mao and I kind of came up with, which uses the network as seen. It tries to collect network data while the RDS is unfolding, uses the seen network to kind of direct the sample in new directions, and then come up with better kind of results from that. We tested this on like a very simple kind of theoretical case. The idea here is if you're sampling the black nodes and you end up at node 7, you really want to sample node 1. You don't want to sample node 8. And so we tried to say, how could we design a privacy-protecting data collection procedure that recognizes node 1 is in our sample, we want to push them over here, not have them go up there. And so we did that by asking minimally identifying information about each person. In different surveys, we've done different things, including like initials and attributes. Other times, the last 3 digits of their phone number and some attributes, other things like that. But we did that, and then we created differential incentives, or we explicitly directed them to sample the 1 case in this circumstance, rather than the number 8. So it collects network data, uses that information to kind of recover the sample frame and push the network towards exploring the network as quickly as possible to look for parts of the network that have been underexplored. And there's a couple details to this that I'll skip over, but the upshot is that it tends to uncover the underlying population social network relatively quickly, which then allows us to make a better kind of case-by-case recruitment and greatly reduce the amount of variability in the samples that we get. An example in this case is here's sort of the confidence intervals of RDS samples, or confidence intervals of samples in red and green, the actual sample mean in blue. RDS, as the sample size gets larger, those confidence intervals are converging very slowly, right? In traditional random sampling, they converge very quickly. In RDS, they converge very slowly. What we see is that in our network sampling with memory approach, as well as in kind of different variants that think about different ways of collecting the data, that confidence interval is collapsing very quickly to being very close to the population mean, which leads to, it's not an estimated confidence interval, but an actual empirical confidence interval of running the sample hundreds of times on the same network. Which means that it's approximating the efficiency of a simple random sample at the same size. So you're collecting this data and you're getting, say, if you sample 200 cases, it's got the same statistical power as a simple random sample of 200 cases. And this worked well across a variety of different kinds of circumstances. We've also done empirical studies of this, including recent work by Giovanna and Jim, where they did a test against an actual known population, where they fielded it in the actual population. They fielded this NSM approach, and it approximately replicated the kind of various features of the underlying population. You can also learn a lot about the network from the data collected from this. For instance, this is network sampling with memory network, our estimation of a kind of Chinese immigrant community in Tanzania. And you can see the clustering of origin province in that network based on this. So to conclude, I want to emphasize that there are lots of possible exciting things with network sampling. One of the challenges is typically in network sampling approaches, the network itself is not the item of interest. Typically, it's using the network to gather the data. Network sampling with memory is sort of a bridge between that because it does also feature the network as an item of interest. But we often need to think about the classic methods for sampling, kind of an understanding, collecting data on social networks, which I think leads well into the talk that Jimmy's going to give next, because those kind of considerations really do play a central role here in thinking about how do we best learn about social networks. And I think by learning more about the network, we can come up with sampling procedures that more effectively use that network. So thank you very much. Questions? Yes.
I know a lot of it was individual, but I study like organizational level. Can you do that too? With like, I study intimate partner violence networks, and rural communities tend to be very informal. But I'm interested in who talks to who and what, you know, who's connected to whom.
So there are a number of RDS studies of intimate partner violence. In fact, one of the good web-based ones that I was referring to was about this among migrants from, well, they were sampled in Costa Rica, but from Central America. And there are some intimate partner violence RDS surveys in Africa as well. But I've never seen anyone try and conceptualize the unit of analysis as like organizations. Is that what you're asking?
Yeah, like macro level.
I have not seen that. I mean, in theory, I think you could think of it like the organization representative referring you to another organization, but I've not seen that done. From a mathematical standpoint, I don't see anything tremendously wrong with that. It would sort of depend on who you sample and how well they know, say, the links between different organizations. Like if you talk to someone in charge and they know everyone at other organizations, or they know all the organizations they're interacting with, versus someone who's maybe an intern or something and doesn't know those things, you could end up with potential severe biases. But in general, in principle, I don't see a problem with that.
I was wondering, when we look at the RDS sampling, it always is kind of like top, bottom, right? Has there been studies where you connect like people, like let's say, you know what I mean?
Yes. Yeah. So this is exactly that. RDS surveys are, each chain is independent of the other chains as it's sampled, because nobody can participate more than once. And we're not learning anything about the ties they have beyond who they recruit and their popularity, right? So it ends up that you have this kind of a chain, and it goes down, it doesn't connect to any other chain. Those cross ties are not typically enumerated. That's one of the big advantages of the network sampling with memory procedure, is because we're collecting some network data from everyone who participates, and that network data is minimally identifiable, we can make kind of probabilistic matches that I nominated JADA, and he is wearing a green shirt, and you also nominated JADA, and he's wearing a green shirt, and that's probably the same person. So we can learn about that. And in this kind of network, that's exactly what we saw, is that there is a fair bit of cross ties. And people are sort of nominated by multiple individuals, et cetera. Does that make sense? Does that answer?
My other question was, you were talking about sampling with replacement. Like, can you give an example? Like, I have a hard time visualizing. Like,
Oh, yeah.
How would you like?
Yeah, so sampling with replacement is, yes. The second question is about sampling with replacement, and give an example. So sampling with replacement is, you've got a bag of different colored balls in it, and you take out a red ball, and you put that ball back in, shake it up again, take out a ball, and it might be red or whatever. Sampling without replacement is you take out a red ball, and you set it aside, then you reach in again, you take out, say, another red ball, and you set it aside. And the third time you reach in, there's no more red balls in there. So eventually you kind of converge to kind of a biased level of estimating like what's in there based on what you've already sampled. Does that make sense?
Yeah. And so how would that apply here? Like, how
So
would-
RDS prohibits individuals from participating multiple times. So if you initially sample, say, lots of people who don't use condoms, then the subsequent individuals in the network are less likely to not use condoms. Does that make sense?
Okay. But you're not influencing that. It's just a concept.
It's like you don't let people participate multiple times, which is why to simplify that concept away, you have to assume that the network is much larger than the sample size.
Related to that question, are you controlling for this, like with the coupons and who's coming in and enrolling? Is that where you're checking whether they've participated or not?
Yes, that's typically the case. Even in practice in the field, it's not particularly well done. I've seen different studies. Often it's, I think they use methods to try and fake people into thinking that they can really identify them. Like I've seen things where they're like, well, we're gonna measure your wrist circumference and your elbow to forearm length, and that's like a unique identifier of you, even though it doesn't really work. So like, it works well if you've got one research coordinator and they're good at faces and things like that. It doesn't work well if you've got, say, 10 people in and out of the office. They try to prevent that from happening, but it's not a perfect solution.
Yeah, I think about this, and maybe this is what the sampling memory is, but if you know that there's a bottleneck, like if you already have a sociometric network, can you just see across the network?
So I think if you know the network exists and there's a bottleneck, then you don't need to do RDS, right? That's sort of the nature of it being a hidden population. But the network sampling with memory approach is assuming we know nothing about the network, and I used to play like video games like Zelda and stuff like that, and you're walking around and the map isn't revealed yet, and you see more of the map progressively. Network sampling with memory is saying we're learning about the map as we're walking around it, in this case the network, and we're also going to try and explore the areas that are currently unexplored in the network to learn as much as possible about it so we can make the best decisions about who to recruit next. Over here, you had a question? One of you two.
Yes. I was just wondering, I could talk more about the offering bias, just because we're collecting data, we know that people are not kind of jumping up and down to participate in surveys, it's kind of like uploading. So if you come with two pupils, people are not really, I am going to go and go give them to people, how does that work in practice?
So the question's about like the kind of biases in kind of offering coupons in the community. In general, people that participate in RDS are inclined to participate in surveys. They probably tend to think others are inclined to participate in surveys. And they're incentivized through the dual incentive structure to hand out coupons to other people to get them to participate. So in general, like RDS tends to find that when you ask people how many coupons did you distribute and stuff, it tends to be a pretty high number. The unknown question is how many people did you have to approach to get those coupons out? And that's often less well tracked, but can lead to more severe biases in our estimates. In the back here.
How do you track that, like offering?
So that secondary interview procedure, typically, this is the real advantage of that dual incentive structure, is you actually get a second interview with the same people, and you can ask a small number of questions about things that allow for asking questions about diagnostics, for instance. Like, how many people did you try to give the coupons to? And they refused. In the back there.
Thank you for your presentation today. In terms of coupon management and respondent tracking, do you have any best practices or tips that you found helpful to kind of monitor that process?
Yeah, there are a variety of coupon tracking kind of softwares out there. The older one was Coupon Manager. There's spreadsheets that the WHO puts out, and I found that they all work pretty well. One best practice, though, that I think is underutilized is directly recording the time or at least the day that people redeem the coupons. In contemporary survey practices where you're entering stuff online and stuff like that, that is recorded. But a number of the more recent RDS estimators take into account the timing of coupon redemption to kind of improve the estimation procedure. Because say you get a lot of coupons trickling in versus all at once, they suggest different things about the network and how saturated it is. So directly recording that is useful.
In traditional RDS, I'm still a bit confused on how we approach weighting when we don't know much about the overall population.
Right, so the weight, there are a couple different weights out there. The most basic one is this, where you take people's degree over the sum of all degrees in the network, which is I believe a Hayek estimator Thomson-Horowitz estimator to estimate popularity. So it's sort of like your relative popularity. The more popular people get a smaller weight, the less popular people get a larger weight.
So those would be respondents that receive multiple coupons?
No, it's their degree. How many people they report knowing in the network. The inverse is here is what makes it that the more popular people are less, get lower weights. So if I say I know 1,000 people, and you say you know 10 people, my weight will be substantially lower than your weight.
I have a question about the weight. So, do we determine the weight based on the people's response in the survey related to what's reported in literature?
Relative to what?
What's reported in literature about, like, for example, we are starting to look at all of them. We know they are like average, maybe, let's say.
No, the weight is typically against all other sample participants. So you're just gauging sample participants against each other. It's a relative probability sample. So people say, I know X number of people. Other people in the network say they know Y number of people. You take what the individual said, their degree inverse, over the sum of all degrees in the network, in the sample.
If we weigh against the rest of the sample, then how do we know that our sample is representative? Or is it a good sample?
So the theory of random walks suggests that if you were to have a single non-branching chain moving through the network started from a random place, that if it goes far enough into the network and you reweight that by their degree probability, it is representative of the network. Like it's a mathematical, I can give you some citations to it, but it's a basic kind of proof. The same idea works, underlies the logic for like early Google search ranks, for instance, that you can estimate the probability of like a random surfer ending up in a part of the network through a degree-based weight, as long as it's a connected network.
Thank you.
Thank you.